In this problem, we need to find the zeros of the polynomial function f of x equals negative the quantity x plus 3 all squared times the quantity x minus 2. We need to state the multiplicity of each zero and the behavior of the graph at each zero. Then we need to find the degree and the leading coefficient of the function, and finally sketch the graph of the polynomial. Well, how do we find the zeros of any function? We set the function f of x equal to 0, so I'm going to set this whole expression equal to 0. So I have negative times the quantity x plus 3 all squared times x minus 2 equals 0. And now, using the zero factor property, you have a bunch of things multiplied together equal 0. Set each of them equal to 0. Remember, this negative means I have a negative 1 in front, but negative 1 cannot equal 0. So I'm just going to have x plus 3 squared equals 0. X plus 3 squared equals 0 when x plus 3 equals 0. Subtract 3 from both sides, we get x equals negative 3. Now setting the factor x minus 2 equal to 0. Add 2 to both sides, I get x equals 2. Now we've found the zeros, we need to look at the multiplicity and the behavior of the graph at each zero. We're going to have a lot of information, so I often find it helpful to write the information in a table like this. I start with my factor. So here I had my factor of x plus 3 all squared. The 0 that went with it was x equals negative 3. The multiplicity is how many times did this factor occur? Well, it occurred 2 times, so the multiplicity is 2. So the multiplicity is an even number, and that means at the 0, the graph touches the x-axis and turns around. Looking at our next factor, I have x minus 2. Its 0 was x equals positive 2. How many times did this factor occur? Just 1 time. So its multiplicity is 1, which is an odd number, and that means that the graph will cross the x-axis at that 0. Next, I need to find the degree and the leading coefficient of the polynomial. That would be very easy if my polynomial had been given in standard form, but it was given in factored form. So I'm just going to rewrite my polynomial f of x to equal negative 1 times, instead of this, I'm going to write it in expanded form. I'm going to write x plus 3 times x plus 3 times my last factor of x minus 2. And if I actually multiplied these out, where would the highest degree term come from? It would come from multiplying negative 1 times x times x times x. And if I multiply all of these together, I'm going to get negative x cubed plus a whole bunch of other terms of lesser degree. So the only one I'm interested in is my leading term of negative x cubed. So I'm ready to find the degree. What's the degree? The degree of my polynomial is 3. The leading coefficient is the number in front of my x cubed. It is a negative 1. Now I can figure out the end behavior of my function. So the degree is odd. That means both ends are going to point in opposite direction. And if the leading coefficient is negative, my graph is going to start up to the left and go down to the right. So if I needed to describe the end behavior, I would say it rises to the left and it falls to the right. So I'm going to pause the video while I get my graph paper. Here is the grid that I'm going to use to sketch the graph of f of x. I've put a scale on my x-axis, but I haven't on my y-axis, since the only y value I've used so far is y equals 0, which is the y-coordinate of every x-intercept. So I've rewritten my function up here. We already found the degree was 3, the leading coefficient was -1, which meant the graph rises to the left and falls to the right. So that's where we start with sketching. So here I have the part that rises to the left and falls to the right. Now we need to work with our x-intercepts or zeros. I'm going to start working from the left to the right. So my first 0 I found working from the left was x equals -3. It had a multiplicity of 2 and it touched and turned around. Since this is where my graph started on the very left, it means my graph's going to have to come down, touch, and turn around at x equals -3. So let's graph that. And now we have to look at our next 0 that we found. And that 0 was x equals 2 with a multiplicity of 1. So it is going to cross here at 2. And does that look like it's going to work with our end behavior? Yes, the graph's going to come up here, go down, and match with our end behavior. So let's graph that. So now I have a sketch of my graph. We do not know how high this graph goes here. We don't know where it's going to turn around. We need calculus for that. But we're just sketching the graph. It is always good to have a checkpoint, and the checkpoint I'm going to use is the y-intercept. So we're going to set x equal to 0. That means I put a 0 in for this x, and this x. So f of 0 is negative the quantity 0 plus 3 all squared times 0 minus 2. Well, 0 plus 3 is 3. 3 squared is 9. And 0 minus 2 is -2. So I have -1 times 9 times -2, which is positive 18. So my y-intercept is 0, positive 18. Does that match with what I found here? Yes, I definitely have a y-intercept that is above the x-axis. So I know the y-coordinate of this point is positive. That helps check that we've graphed this function correctly.